And like.
Okay, here we are at Julia Davis-Porada's ISP presentation. I'm just going to go over what she has described, what she's
I did
done.
not do my capstone.
These are various.
I help with that.
Yeah.
Oh, that's the TED Talk.
Yeah. That was so much fun.
Oh, Dr. Ladner.
Okay, and she's going to present all these with how to get a close-up.
Don't get me.
No, it's okay.
What?
I'm glad it's almost the end of the term. How are you?
That was a very well thought out response.
Don't think I haven't been thinking about it.
Our last class on Saturday is an hour and a half ballet class.
Oh.
Really appreciate it. I didn't think anyone was going to come. Everyone laughed at my chapel announcement. I don't know why, but apparently the name making more ergonomically sound point shoe is a little fancy for all of this. But basically, before I start talking about my project, I just want to thank Mr. Wardrop because he's my project advisor and has dealt with me being in here with all of his classes and sawing for like 2 hours straight. And Ms. Windsor and the ISP committee for creating a program that allows students to do this because it's amazing to not have to forfeit academic credit for doing something that, I mean, I enjoy my classes, but something extracurricular that I enjoy. But basically, point shoes are absolutely the most horrible thing, and all of them here can attest to that. Today, we were on point for 3.5 hours, and by the end,
Today?
all of us were like, doing a little stumbling. And just to show you, this is how I started with my project, was just looking at what was in shoes. Like,
Okay.
why would you want to wear that? It's like burlap and cardboard, and as you sweat, it just falls apart. And like, so you're supposed to stand on this part, but what happens when this corner decides to get really soft, and then you're like this the whole time? And it's like, you can only wear a shoe for so long, and it's not an inexpensive thing, and I just don't really see why we're wearing this. One of my reasons I started this project was because athletic wear is just constantly improving, and safety is really important. So my goal for this project was to make a more durable, more comfortable, and safer shoe. So I kind of started just by researching. So I would like peel these apart and see different types of shoes, what it's made out of, and I took notes and looked it up. And then I looked at gainer mittens, which are the shoes that I wear, and I think they're great. And they're the only shoe that has taken any step towards synthetic material. So that's this shoe. And I just kind of set up a little thing to show you. This is what's inside a gainer mitten. It's pour-on plastic. It's made with injection mold material, with injection molding. And so this is the only shoe that's not handmade. This is what's inside a Russian point. These do the same thing, and that just doesn't really make any sense. Like, standing on this, you know, however many pounds of a dancer is not very helpful. So I decided to go the plastic route and create something more durable. But my problem with gainer mittens is that the material is so thick right under the box here that it's really difficult to roll up. See, even as I do it with my hand, I just kind of have to bounce up, and that is one of the many complaints from dancers about gainer mittens, is that they're cheater shoes, because you don't have to work as hard when you're wearing a plastic shoe as when you're wearing cardboard. And I can understand the no pain, no gain mentality, but not when it's people's career and they could risk getting injured and then they have nothing to do. So my idea was to take this pre-arch shape, but then cut it here. And I kind of did this with this and doubled the thickness to figure out, how thick do we actually want this material to be and how thin do we want this to be. I went to in Manchester, there's these plastic companies. I went to like 3 different places and got sheets of plastic, which I have little pieces of here, and I have the full sheets. So ultra high molecular weight plastic, which is like on the bottom of snow plows, like really durable stuff. Polycarbonates, which is what most of our lab goggles here are actually made out of, and then some like polyethylenes that are just like I could bend it and it will stay there. So it's not exactly what you want, but you also don't want something that's so hard that you can't bend it at all. So I took these plastics, cut them into the shape of this. This is the endless song that I'm talking about it. And then with a heat shrink gun, which is actually used to put plastic on wiring. It's like a really hot hair dryer. Sit there, hair drying these plastics until it starts to melt, and fold it into the shape that I want it to be. And basically that's what I did with all of these plastics. And then I took them to the ballet company and had them basically slide it into one of the shoes and tell me on a scale of 1 to 10 how hard they were, and if how that compared to their current shoe. And I found that 2 things, that the ultra high molecular weight plastic was best life, and then the next best life was a tie between the 2 polycarbonates, but the one that's 1/8 thick and the one that's 3/32. And I thought this was very interesting because in the standpoint of if I was going to actually manufacture these, that would be something really good to know, rather than buying thicker, more expensive plastic where you're going to have to, 1, spend more money, and 2, you can only fit so much into a shoe to make it aesthetically pleasing, and that's really important for dance. So if you can cut away 1/16 and add, 1 more little bit of cushioning, that's going to be something really good by a business standpoint. So that was something helpful. Basically what I did was move on to the process of putting on different types of foams and cushionings. I used things from bed cushions, like what people put on their mattress pads, remember there were, to actual foot insoles. And this particular Dr. Scholl's insole was best liked by people. But in between the research and coming up with a product is this stuff. Figuring out how to shape and how to make what I needed to. So I met this, or not met, but talked through the summer with Richard Stess, who owns STX Casting Soft Company, which is basically to make molds for orthotics. And so he sent me, very generously, a bunch of samples of his socks. And so basically I was able to wet these. They get really hot, and I sit there with it on my foot. So the whole, all the engineering class in here, I was sitting back by the sink with this thing on my foot. Parents' weekend, someone walked in, what are you doing? But I was able, this is very helpful because I was able to use it to mold, and actually ones that didn't survive because I filled them with plaster. This is plaster of Paris. Mix it with water. Pour it in. I had to break the outside off because I wasn't really thinking in advance about how I was going to get it out. So I was hacking it off with scissors, but ended up with these, which allowed me to actually do the melting of the plastic. I sit there with this shape so that I didn't have to touch it because it was really hot. So I would just place it on here and let it mold. All of the plastics that I have are heat molding plastics, so that means when you heat them up and shape them, when they cool, they'll stay in that shape. I mostly worked with the shank, as I've been talking about, but one thing that is obviously important is the box, which is the part that you stand on. This is an example of a box. Just it's glue and burlap, and as I was saying, they get soft in certain places. This is the front of a Gainer Minden one, and again, I have the problem that it's too thick. So, using Google SketchUp and Aaron Weiss last year was his engineering design project was solely learning Google SketchUp and AutoCAD, and he really helped me. And so this was a shoe that I actually found in the inventory of Google SketchUp and modified to work for me. So it's kind of pretty cool, this whole program. And I know architecture uses a lot, but basically my attempt to print it out was this on the 3D printer. And it was not happy. It did not like it. But Aaron's design on CAD, which is a more high-tech program, did work. You know,
So,
we thought that this
yeah.
was going to fit my foot. This is engineering at its finest. Like, they're like, oh yeah, like 1 centimeter, and then you're like, it prints, and it's this big. You know, we moved up a little bit, and then finally, this actually, the problem was that it was so long by the time we got it to the right width that I had to then cut off the whole back part. It's over there in the box, but it's been really neat. I was showing some people before, like the 3D printer and how it works, and being able to use 3D printer. One thing I learned that's just kind of fun fact. There's actually a worry now because they're getting so good that people can print weapons. I just thought that was fascinating, like that you could print a gun and shoot it. I just thought that was amazing, and so that's something to do with my project. Fascinating, really. So I actually used one of these casting socks as a box. I thought it was a really good material because it was sturdy, but it was really easily shapeable to my foot rather than having like one set for each person. Because I really think that is a problem. Like my feet are like triangles from dancing for so long. Like wearing pointe shoes, they just go in, and so everyone has really different feet, and perhaps having a company where you can get it shaped to your foot would be something that, you know, pointe shoes could be going in the future. So I used those and actually molded to my foot, and it's a lot more comfortable than just putting your foot in a pointe shoe, because another problem is that it takes a really long time to break them in before they get comfortable. And so by the time they get comfortable, then they're too soft to wear, and then you have to get a new pair. So it's like this never-ending unhappiness. So I really think there's a lot of room. So engineering-wise, basically, I started with research, moved through shanks and boxes and plastics, and I have a nice burn on my leg to prove my plastic melting, and kind of ended up. I know the hardest part of this project for me was trying to sew together some satin to cover it, and I just gave up, honestly. It was so bad, like, it's so lopsided, like trying to actually cover it. I was able to, last spring, to make it just out of some blue fabric we had in in the engineering lab. So this is like, if I could take out what's in here if it wasn't glued down and put this in, that would right now be my ideal. Have an outside and an inside. But I really think that there's an interest in this project. I think there should be more of an interest for dancers, and in an entrepreneurial idea. Like, there's a real opening in this area. There's one company that uses any new material, and they don't even seem like they're going to change. I interned at Gainermanden this summer, and they seem to be totally set in their ways already, and thought that I was coming in to steal their information. Like, it was very weird. But I really think that there should be constant change, just like other athletic wear. So this is something that I hope to continue in the future. But if you have any questions.